In this lesson, we developed the idea of resultant vectors, vectors that are the result of a sum of other vectors. So let's create a vector A. A would have a magnitude of 15.0. Normally would have units associated with it, but let's just leave the numbers to make it easier for right now. Let's say it makes an angle with the x-axis of 32.0 degrees. Then let's say that we have a vector B. We will give B a magnitude of 25 in some units, the same units as A, and we will have it make an angle of 67.0 degrees with the x-axis in this direction. What we would like to find is the resultant vector R, where R is the sum of vector A and vector B. Let us observe what happens pictorially when we add the vectors together. Here's vector A running in this direction. Here is vector B running in this direction. Our rule says we create the resultant vector by starting with the initial tail of vector A and ending at the head of vector B. When we write it in this form, we can say we have the picture of the resultant vector R is the vector A plus B. We would like to know mathematically how to describe R. How do we do that? We will do that by breaking A into its x component and y component. We will break vector B into its y component and its x component, and then we will have vector C. So here's vector A. Magnitude of 15 makes an angle of 32.0 degrees. So we can write A as the magnitude of A times the cosine of 32 degrees in the x direction, plus A, the magnitude of A, times the sine of 32 degrees in the y direction. When we write this, we have A is equal to 15 cosine 32 degrees in the x direction, plus 15 sine 32 degrees in the y direction, and now we have the vector A equal to 12.7 in the x direction plus 7.95 in the y direction. Because we had three significant figures in the beginning up here, therefore I kept three significant figures in each one of these. Now let's do the same thing for vector B. Vector B has a magnitude of 25 in this direction and makes an angle of 67 degrees. So we can write the vector B is equal to 25 cosine 67 degrees in the x direction plus 25 sine 67 degrees in the y direction. Then we can write B as 9.77x in the x direction plus, but I notice the y component is negative. This is the negative y direction. So what I cannot do is make that a plus. I must show that this is a minus because the y is minus 23.0 in the y direction. Now we develop the resultant vector R is equal to the sum of vector A plus B. And I think you'll find it easier to write this as R is equal to A plus B, like this. So we have A is equal to 12.7 in the x direction plus 7.95 in the y direction. We have vector b is equal to 9.77 in the x direction minus 23.0 in the y direction. We then add those two vectors together to get the vector r. When we do that, r is equal to 22.5 in the x direction minus 15.1 in the y direction. Pictorially, we have r. What we would like to do now is, let's look at r again. I have r to be the sum of a plus b, and it turns out to be 22.5 in the x direction minus 15.1 in the y direction. Does that look right? Well, I think it does. If I look at the picture up here, I have a running along this way, I have b running along this way, and we certainly need a negative component of y for r, which we have, and we need a positive component that's about the size of b, and we have that. So now we can look at theta, and let's just start another page and just look at r by itself. Here is r by itself. R is 22.5 in the x direction minus 15.1 in the y direction. If we look at the parallelogram completed by r, we see that this is the y, and depends on where we look at, it doesn't matter, this is the x. So here is the x, and here is the y. So the tangent of theta, this angle, is going to be y over x, which is minus 15.1 over 22.5. Taking the arctangent of both sides, we get theta equal to the arctangent of minus 15.1 over 22.5, and we get an angle of 33.9 degrees. And that looks reasonable for my drawing. That probably looks about like what it is. Now let's look at r. It runs down like this. Here is the x component. Here is the y component. We want to find the magnitude of r, so we know from Pythagorean theorem that r, the side of this triangle, is going to be the square root of the x component plus the y component. In this case, we have r is equal to 22.5 in the x direction minus 15.1 in the y direction. So the magnitude of r, this would be the magnitude of r, which we can write as, looks like an absolute value sign, but it means the magnitude of the vector r, as being the square root of x squared, so I have 22.5 squared, plus minus 15.1 squared, the square root of the sum of the squares, and I get 27.1 as a magnitude of r. Finally, I can sum up everything I know. R is equal to the vector A plus the vector B. R is equal to 22.5 in the x direction minus 15.1 in the y direction. The magnitude of r is 27.1, and the angle that r makes with the x-axis is a minus 33.9 degrees.